So here we have another application of the ideal gas law, but dealing with the density of a gas. So if we have a gas, the density of a gas is measured at 1.853 grams per liter. Notice, usually for liquids and solids we measure density in either grams per milliliter or grams per cubic centimeter for a solid. But for gases, because they're so spread out and they're so much less dense, we typically do it in grams per liter. So 1.853 grams per liter at a pressure of 745.5 millimeters of mercury at 23.8 degrees Celsius. What is the molar mass? Once again, we're going to use the ideal gas law. The ideal gas law, as you remember, PV equals nRT. We also saw that N is the same as, so PV equals grams over molar mass, RT. However, notice, density is grams over liters. So I can go ahead, and in this case, we want to solve for molar mass. I can rearrange this equation. But really what I need to know here is N. But I don't have a volume. Well, I sort of have a volume. I see there at 1 liter, there's 1.853 grams. So first I can go ahead and solve this for moles. So moles equals PV over RT. Because now I can go ahead and substitute numbers in. My pressure, pressure's in millimeters mercury, I need in atmospheres. So to do this conversion, I'm going to go 745.5 millimeters of mercury. And we know there are 760 millimeters of mercury in 1 atmosphere. I can now plug that in over here, 0.9809 atmospheres, times my volume. I can assume I have 1 liter. Over my R, 0.08206 liter atmosphere per mole Kelvin. And my temperature. Temperature's in Celsius. Let's convert. 23.8 degrees Celsius, 273.15 K. 59692, so 296.95 K. I can always have more significant figures. And this is going to be my number of moles. So N equals 0.04025 moles. In 1 liter, how many grams did I have? Well, I had 1.853 grams in 0.04025 moles. We know that molar mass is grams per mole. So if I do this simple division, I can come up with my molar mass. 46.04 grams per mole. One way to solve this problem. Let's see another way. Now I can rearrange this form of the equation, knowing that I want molar mass over here, because I want to solve for molar mass, and I know the grams per liter, which is my density. So I bring volume down here, and I end up with grams times RT over P. That is going to give me molar mass. Again, all I did was I moved molar mass over here. I divided both sides by PV. This I grouped together because that's my density. So now molar mass is going to equal 1.853 grams per liter times R times T over P. My P I calculated before, changing the millimeters of mercury into atmospheres. And now I can solve for molar mass directly. This is another way to do this. When I do this calculation, my molar mass comes out to be 46.03 grams per mole. Both answers come out pretty close to each other, just depending on rounding and other types of significant figure. So my answers come out the same. Either do it directly through this type of equation, or do it this way, solve for moles, and then take my grams per mole, assuming I had 1 liter. 2 different ways to solve this density type problem. This is a very typical problem that we would use density for.